Hello grade 10. So today we're going to be doing the chapter 3 review, and then once you're done the review, then you're going to work on an open book test that will be due before our next class, which is Thursday. So there's a handout on Teams, a review handout that you should print out and fill in as you watch this video. First we're going to go through a bunch of definitions and that sort of thing, and then we'll do a whole bunch of examples from the textbook. So at the top of your handout there it says properties of parabolas. Quadratic relations produce parabolic curves which have different properties, including, so when you have a quadratic, that gives you a parabola. That's something you need to know for the test. A parabola is the shape of the line that is produced by a quadratic. So it could be that way or open down like that. So the first property is the vertex. And the vertex is either the highest point or the lowest point. So if it's the highest point, that would be a maximum value. And if it was the lowest point, that would be the minimum value for the problem. The Y-intercept, that happens when x equals 0. So that's where the line crosses the y-axis. This is the Y-intercept right there. There's a potential of two x-intercepts. So those are the zeros. So you can either have 0 zeros if your parabola is up there or say down here and it opens down. Or you could have 1 0 if the parabola was on the vertex or the vertex was on the x-axis, or anywhere else it would have 2, whether it opens up or opens down. Then it will cross the x-axis twice. And those would be the x-intercepts, also called the zeros. The axis of symmetry is the midpoint of the zeros. So it's where the parabola is cut in half. Midpoint of zeros. So if this is my parabola, then halfway, that's the axis of symmetry. And it's the x-coordinate of the vertex. Two other things that you need to know before we move to the next heading. For quadratics, the second differences are constant in a table of values. If the first differences are constant, that would be linear. If the second differences are constant, that's quadratic. And the a value in the equation, so the equation for a quadratic is y equals ax squared plus bx plus c. This number in front of the x squared is the a value. If it's positive, if a is positive, the parabola opens up like this. And if a is negative, the parabola opens down like this. Okay, so those are two more properties to add on to the list there. All right, the next heading is the different types of quadratic equations. So there's two different forms that we talked about. The first one was factored form. And the factored form looks like y equals a x minus s x minus t, where s and t are zeros, are the zeros of the quadratic. And then the other one is standard form. And that is y equals ax squared plus bx plus c. And from both of these equations, you can see whether the parabola opens up or down by looking at the a value. If it's positive, it opens up. If it's negative, it opens down. And then from standard form, the c value is also the y-intercept. So that's helpful for graphing and that sort of thing. So that's actually part of the second, or the next heading, which is properties from equations. So each form of the quadratic equation reveals different properties of the parabola. So factored form, the a value is the direction of opening. So whether it opens up or down. And then s and t are the zeros. For standard form, a is also the direction of opening. and C is the y-intercept. All right, the next heading says converting between equations. To convert the quadratic equation from one form to another in order to find different properties, the following techniques are available. So you can either expand or factor to switch back and forth. So if I have an equation that's in factored form, so y equals 3, 2x plus 1x minus 4, then I would need to expand this in order to get it into standard form. And if I had an equation in standard form, like y equals x squared plus 3x plus 2, then in order to get it into factored form, I would need to factor. And we'll do some examples of that later. All right, the next heading says factoring techniques. Factoring involves 4 essential questions or techniques. So if you're asked to factor or you need to find the zeros, that means you'll need to factor. There's 4 things you can do. First, check if there's a greatest common factor. So if I have 30x squared plus 20x plus 40, I can take a 10 out of each term. So then I would do that. That's taking out the greatest common factor. So then I would have 10 bracket 3x squared plus 2x plus 4. And now it's a simpler equation in the bracket for me to factor. So that's just the first thing you do in order to simplify. The second thing, you check if it's a difference of squares. This is a special type of factoring. When you have only 2 terms and they're separated by a subtraction sign, and both terms are perfect squares. So for example, x squared is a perfect square. You can take the square root of it, and 81 is a perfect square. So in order to factor this, you would just take the square root of both terms. So the square root of x squared would be x. The square root of 81 is 9. And then you would add 1 and subtract 1, and now that's factored. The third question or technique is you need to ask, is this a trinomial of the form x squared plus bx plus c? So what this is asking is there a number in front of the x squared? If not, then you find 2 numbers that multiply to c and add to b. So for example, if I have x squared plus 3x plus 2, I would need 2 numbers that multiply to 2 and add to 3. So those would be 2 and 1. So my brackets will be x plus 2, x plus 1, and that's how I factor. And that's just a little bit different from the fourth question, which says, is this a trinomial of the form ax squared plus bx plus c, where a is not 1. So in this case, there's a number in front of the x squared, and then we need to do some things a little bit differently. So if I have 4x squared plus 6x plus 9, then I would need to multiply the 4 and the 9 to 36. Now I need 2 numbers that multiply to 36. And add up to 6, that middle term. Okay, so this one doesn't actually work because I just made it up, but we'll do another example of this in a minute where it actually does work. Okay, the next heading says solving quadratic equations. To solve quadratic relations means to find the unknown value, which means you must be given the value of the other coordinate. For example, they'll give you the y value and you need to find the x value. The unknown value can be found one of 2 ways. You could graph it to find the answer. It's not always accurate because when you graph, you might make mistakes. Your scale might be a little bit off. It won't be perfectly accurate. Or you can use algebra. So in order to do this, you'll need to move everything over to one side so that the equation equals 0 and then factor it. Now underneath there it says if it is in factored form and something there's a number on the other side of the equal sign, then you need to expand everything out, then move the number over, like the 20 in this case, and then refactor it once that 20 is included on the left side in order to get it in as part of the problem. Okay, we'll do some examples now. So if you could turn to page 323 in your textbook. Page 323, and we'll start with number 2. So number 2 says, examine the pattern of numbers. Number 1 equals 6, number 2 equals 20, number 3 equals 42, number 4 equals 72, and number 5 equals 110. I'm just going to write those down for a minute. So I have 6, 20, 42, 72, 110. All right, letter A says, find the next 3 terms in the sequence. So in order to do that, I'm going to find the difference between them. So 20 minus 6 is 14. 42 minus 20 is 22. 72 minus 42 is 30. And 110 minus 72 is 38. Now there's not really a pattern there that I'm seeing, so I'm going to find the next difference. 22 minus 14 is 8. 30 minus 22 is 8. And 38 minus 30 is 8. So I know that this is going to continue on by 8s for the second difference. So make 3 blanks for my missing terms. I'll need to find these differences here. And then I know that these ones will be 8. So if I just keep going up by 8, so 46, 54, and 62, then I'll do 110 plus 46 is 156. 156 plus 54 is 210. 210 plus 62 is 272. And I know this is a quadratic because the second differences are constant. And that's part B. Second differences are constant. Okay, next I'm going to do number 4C, which is actually on page 326. Number 4 says, each pair of points lies on a different parabola. Determine the axis of symmetry of each parabola. So, the points are 16, negative 2, and negative 18, negative 2. And since both the y coordinates are the same, I know that these are going to be exactly across from each other on my graph, which means that to find the axis of symmetry, it would just be halfway between those two. So I'm just going to take the x coordinates, and I'm going to find the average of them. So 16 plus negative 18 divided by 2. Is it positive 18? No, it's negative 18. Okay. So 16 minus 18 is negative 2 over 2 is negative 1. So the axis of symmetry is negative 1. Because that's halfway between the two. All right, next we're going to do number 5 right below it. The zeros of a quadratic relation are negative 2 and 5, and the second differences are all negative. Explain whether the optimal value will be a maximum or a minimum. So we can actually determine this from the second differences. Because the second differences are negative, that means the a value will also be negative. So if the a value is negative, that means the parabola will open down, which means it will have a maximum point. It will have a highest point rather than a minimum. So that's part A. 5B says, what value of the independent variable will produce the optimal value? So what it's asking is, which x value will give us the vertex, what will be the x value of the vertex that will produce the optimal value, which is the y value. So that's the axis of symmetry. So we know that the zeros are -2 and 5. So if we find the point that's halfway between them, then we'll know what the optimal value is. So -2 plus 5 divided by 2 equals 1.5. So the optimal value, or the x value that will produce the optimal value, is 1.5. And will the optimal value be positive or negative? So if my zeros are -2 and 5, and the vertex is happening at 1.5 comma something, we don't know what, that's going to be above the x-axis, because we know it opens down and these are the zeros, which means it will be a positive optimal value because that number is going to be above the x-axis. Okay, next we're going to do 7b on page 328. So 7 says, determine the equation of each parabola. So if you look carefully at the graph, we can figure out what the zeros are. And those happen at 20 and 60. And then we'll need one more piece of information to make an equation. And a good one to use is the vertex. So it doesn't have to be the vertex, it can be any point, but try to pick a point that happens on the cross of two lines so you know that that is a point. So the vertex in this case is 40, 100. So if I need to create an equation, I can either use factored form or standard form. Factored form uses the zeros, which I have in this case, so that'll obviously be the easier one. So I'll start with y equals a, x minus s, x minus t, because that's factored form. S and t are the zeros, so I'll plug in 20 and 60 for s and t. X minus 20, x minus 60. I just plug them in for s and t. I leave that negative. Now I need to find the a value. So in order to do that, I can plug in the vertex for x and y and solve for a. So y would be 100. So 100 equals a. X is 40. (40 minus 20 is 20, and 40 minus 60 is negative 20. 20 times negative 20 is negative 400. In order to get a by itself, I'll divide both sides by negative 400. And a equals negative 1/4. So therefore, the equation is y equals negative 1/4, x minus 20, x minus 60. I have those three pieces of information that I need to complete this equation. So the a value and the two zeros. Okay, next we're going to do 9c on the next page. So 9c says, determine the quadratic equation for a parabola with zeros at -6 and 2 and a y-intercept of -9. Zeros are -6 and 2. Y-intercept is -9. So the y-intercept happens when we cross the y-axis. That's happening down here at -9. Now, in order to properly use this information, we need to write that spot as a coordinate point. So that would happen when x is 0, so 0, -9. And now we can use that point in our equation to find our a value. So again, we'll start with factored form. Y equals a, x minus s, x minus t. We'll plug in what we know, which is the zeros. Y equals a, x minus -6, so that becomes x plus 6, and x minus 2. Then we'll take this point and plug it in for x and y. So we have -9 equals a, 0 plus 6, 0 minus 2. -9 equals a times 6 times -2. -9 equals a times -12. Divide both sides by -12. A equals 3/4. So now in order to put this into an equation, y equals 3/4 x plus 6, x minus 2, with those three pieces of information, the a value and the 2 zeros. All right, next we're going to do number 11, D, F, and J from page 330. 11, D, F, and J. So 11D, expand and simplify these expressions. So 2x minus 3 times 2x plus 3. So expand and simplify, we need to take each term in the first bracket, multiply it by each term in the second bracket. So 2x times 2x is 4x squared. 2x times 3 is 6x. Negative 3 times 2x is negative 6x. And negative 3 times 3 is negative 9. We'll simplify by combining those two middle terms, which are like terms. 4x squared, 6x minus 6x is 0, so 4x squared minus 9. Letter F, 6x minus 2 times 5x plus 7. Do the same thing. 6x times 5x is 30x squared. 6x times 7x is 42x. Negative 2 times 5x is negative 10x, and negative 2 times 7 is negative 14. Again, we can combine those middle two terms because they're like terms. So we have 30x squared, 42x minus 10x is 32x minus 14. And letter J, negative 3 times 2x minus 1 times x plus 4. So when we have a negative 3 out in front, we need to multiply the negative 3 into the brackets, but it's easier to first multiply the two brackets together, and once you have that expanded, then multiply the negative 3 in. So I'll leave the negative 3 out in front. 2x times x is 2x squared. 2x times 4 is 8x. Negative 1 times x is negative x. Negative 1 times 4 is negative 4. So we'll simplify inside the bracket first. 2x squared, 8x minus x is 7x minus 4. Now we'll get that negative 3 into the bracket. So negative 3 times 2x squared is negative 6x squared. Negative 3 times 7x is negative 21x. And negative 3 times negative 4 is positive 12. And now that is fully expanded. Okay, next we'll go to page 331, just on the other side, and do number 13. Express in standard form the equation of the parabola that has zeros at 4 and negative 2, and whose optimal value for y is 12. So when they talk about the optimal value, that's the vertex. So we know the vertex is something comma 12. So we need to find that something before we can use that point in our equation. So that something is the axis of symmetry. Since we have the zeros, we can find the axis of symmetry by finding the average of the zeros or the midpoint. So 4 plus negative 2 divided by 2 is 4 minus 2 is 2 divided by 2 is 1. So this number is going to be 1. And we can now use this point 112 to help us find the a value. So we'll start with factored form. Y equals a, x minus s, x minus t. Y equals a, our zeros are 4 and negative 2, so we'll do x plus 2. Then we'll plug in this point for x and y. So 12 equals a, 1 minus 4, 1 plus 2. 12 equals a, negative 3, 3. 12 equals a, negative 9. Divide both sides by negative 9. 4 over negative 3 equals a. So I need to get this into standard form. Right now I have factored form, which is y equals negative 4 thirds x minus 4 x plus 2. This is factored form. in order to get from factored form to standard form, I need to expand this out. So I'm going to move on to the next page for a second. Y equals negative 4 over 3, x minus 4, x plus 2. And then I'm going to expand. So first I'll expand the two brackets, leave the negative 4/3 in front. X times x is x squared, x times 2 is plus 2x, negative 4 times x is negative 4x, and negative 4 times 2 is negative 8. Simplify inside the bracket first. 2x minus 4x is negative 2x minus 8. All right, negative 4/3 times x squared is negative 4/3 x squared. Negative 4/3 times negative 2 would be negative 4 times negative 2. I'll do it over here. So you do negative 4 times negative 2 is positive 8 over 3. And then x. And negative 4 over 3 times negative 8 equals negative 4 times negative 8 is positive 32 over 3. And you can just leave those as fractions. Okay, number 14 on page 338. Nope, sorry, 332. And we're going to do every other one, starting with A. So number 14 says factor each expression. So A is x squared plus 2x minus 15. So since the A value is 1, there's no number written there in front. I just do the regular kind of factoring. So I need to find two numbers that multiply to negative 15 and add up to 2. So some things that multiply to negative 15, one of them needs to be negative and one needs to be positive in order to multiply to a negative number. So I could have negative 5 times 3, negative 3 times 5, negative 1 times 15, or negative 15 times 1. One of these combinations has to add up to 2. So 5 and negative 3, 5 minus 3 would give me 2. So I'm going to have x plus 5, x minus 3. And that is my factored equation. Letter C. R squared minus 4r plus 4. So two numbers that multiply to 4 and add to negative 4. Now because I need to add to a negative 4, the two numbers are both going to be negative because they need to multiply to become positive. Well, then we need two negatives multiplied together equal a positive. So my options are negative 1 times negative 4 or negative 2 times negative 2. Which combination adds to negative 4? Negative 2 and negative 2. So my brackets are going to be r minus 2, r minus 2. And I could rewrite that as r minus 2 squared. All right, letter E. 6x squared plus 5x minus 1. So in this case, we have a number in front of the x squared. So I need to multiply the 6 and the negative 1 to get me negative 6. Now I need two numbers that multiply to negative 6 and add to 5. So my options are negative 1 times 6, negative 6 times 1, negative 3 times 2, or negative 2 times 3. 6 minus 1 will equal 5, so I need to rewrite the middle term as negative 1 and 6. 6x squared minus 1x plus 6x minus 1. Group them into two groups, see what I can take out of each one. This one I can take out an x squared, an x, I'll be left with 6x minus 1. And this one I can take out just a 1, 6x minus 1. So my two brackets are x plus 1 and 6x minus 1. Okay, I'm going to run out of time, so I need to end the video. So let me know if you have any questions, and make sure you go do your open book test now. Have a good day.